So today's lesson is 7.2, which is called multiplying and dividing rational expressions. Just dividing. So on Monday or Tuesday, or on Tuesday, we tried simplifying these expressions. So now for today's Wednesday, the 24th. Okay, so for today, now that we're multiplying and dividing them, it's again very similar to how you deal with fractions. Whenever we, because we started off the lesson yesterday also with how do we simplify or reduce fractions, and that was kind of the intent on how we were simplifying rational expressions as well. If you think about how we would multiply, for example, Michigan Virtual uses like 2/3 times 1/7, right? All you did was multiply the tops together. Like 2 times 1 would be 2, and then multiply the bottom would be 21, and then we would possibly reduce if it was possible to reduce it. But this one doesn't reduce any further. So that's the idea. But when we're multiplying and dividing with rational expressions, that means with fractions that are not just numbers like this, we might be better off trying to cancel things that are the same, again, by factoring, and then that way it simplifies it a little bit for us. Instead of waiting to just multiply the tops and the bottoms together and then try to reduce it, that would be a whole lot more work. So I have a bunch of examples here for you guys. I'm going to work through with you so that hopefully you'll be prepared for the quiz and understand better about multiplying and dividing rational expressions. So here is our first example. Again, multiplying is exactly what it sounds like. You're going to multiply the top and then multiply the bottom, but only after you factor. So the key part that I would focus on here is factor each expression first, and I'll just put in parentheses top and bottom. That's talking about the fractions, and then multiply, and I'll put in parentheses here that includes canceling out, reducing fractions, and so on. So we'll do all of that as we try out these examples. So here is example 1. We have x squared plus 5x divided by x cubed plus 3x plus 2. And this is what we would have started with yesterday. On Tuesday, we just looked at just one rational expression and we tried to simplify it by factoring first. But now we're multiplying. So we're going to put a little multiplication dot and multiply another expression, another fraction or rational expression to it. So this one is going to be x squared plus 6x plus 5 divided by x cubed plus 7x squared plus 10x. Okay, so we have this equation, or this expression, two expressions being multiplied together, and now we're ready to start simplifying it. So the first thing I would see what to do here is instead of just trying to multiply these, like you'd have to use FOIL or the box method and so on, that would be really complicated. It would be easier if we could just factor each part first, each numerator and denominator, and then cancel as needed. All right, so to start here, the GCF of the first row is x, so, or of the numerator of this first expression. So x is all they have in common, so I factor it out, and I'm left with x plus 5. The reason it's x plus 5 is, again, you're taking one x away here and one x away of this. Do the same thing. I'm going to make one big fraction bar here, because now we're going to multiply for the next one. And I'm going to just put everything on the top of the fraction. Just like here, I did 2 times 1 is 2. I can put everything on one big fraction bar. So for this next one, I have to factor x squared plus 6x plus 5. Feel free to use the little x method if it helps. But you want to make sure, oops, multiplication, that's addition. You want to make sure you can do these quickly. Two numbers that multiply to give you 5 but add to give you 6 would be 1 and 5. So this would be x plus 1 and x plus 5 in any order, but we do have all of those listed. Now do the same thing for the denominators. For this denominator here, I see that they all do share, and I'm sorry, this is an x squared, and I wrote that incorrectly. That was an x squared plus 3x plus 2. This was only an x cubed. But let's go ahead and now see that there's no GCF here. So let's go ahead and factor this one. Again, I'll put a little x here. So the numerator is 2, denominator is 3. So you're thinking of two numbers that multiply to get you 2, but add to get to 3. That would be 2 and 1. So I would write this as x plus 2, x plus 1. That's for the first parentheses or first trinomial, and we got the two factors. Do the same thing for this guy, but what I am going to do is before I write that part down, I'm going to factor out an x here. So this would be x taken out of each one of those factors. So I'm going to just kind of lightly cross that off and say that that's equivalent to this. Now I can factor x squared plus 7x plus 10, and it's not too bad to do that. 10, 7, the two numbers that multiply to give me 10, but also add to give me 7 would be 5 and 2. So finally, I've factored everything. I know there was a lot of factoring there, but you factor until you can't factor anymore, and then we're going to cross off things that are the same on the tops as they are on the bottom. So we have one of these x plus 5s with one of those x plus 5s. We have this x plus 1 and this x plus 1, and that's about it. Nothing else can be simplified. So at that point, now you're going to multiply. Looks a lot easier to multiply something that's left over rather than all of this stuff that was here from the beginning. So we're going to start by multiplying. On the numerator, all that's left is x times x plus 5. Right? These two guys are gone. And the denominator, all that's left is x plus 2, x plus 2, which technically means x plus 2 squared, quantity squared. But in this case, we're going to go ahead and distribute and FOIL. If the answer doesn't tell you how to leave the final answer, sometimes this might be left as x plus 2 quantity squared, but in this case, we're going to go ahead and FOIL it. So the numerator is x squared plus 5x. The denominator would be x squared plus 4x plus 4. And again, the way we're getting this is think outer and inner. That's how we get positive 2x, and positive 2x is a positive 4x. And then 2 times 2 would give me 4. You can definitely write out FOIL or the box method if you need more steps than this, but this is our final answer. So we'll do a few more like this for multiplying, and then we'll move on to division, which is very much the same as well. So number 2 here, the question is 2x squared minus 5x plus 3, and you're dividing it by x minus 2. Okay, and so when we get ready to factor this, let's go ahead and see what we have more to this. We are multiplying this by x squared minus 1 on the denominator, and the numerator would be, let's do negative, or 4 minus x squared. Okay, so the 4 minus x squared looks a little odd. This is like difference of two squares. It is difference of two squares, but it's just written in a different way, so that now when I square root both of those, you end up with 2 minus x and 2 plus x, but we'll go ahead and write that down here in just a second. So let's start by factoring all the parts that we can. So one big fraction bar here. The first one, when you factor 2x squared minus 5x plus 3, you can use the box method. I'm going to go ahead and just use guess and check because it's a little bit quicker. So I know it has to be 2x and x, and then these two, I know it has to be 3 and 1 for the ends here. I just have to figure out the order. So if it was, let's say 3 here and a 1 here, we'd get 3x and the 2x. I want to make them both negatives because that would make it a negative 5x, but also give me a positive 3. Then for this guy here, 4 minus x squared, think of it like dots, difference of two squares. It would be 2 minus x and 2 plus x. I know that looks a little odd with how it looks, but it's very similar to how we do regular dots or difference of two squares. Like for the bottom one, first I'll have this x minus 2 that's already there. And now this x squared minus 1 would be x minus 1 and x plus 1. So right off the bat, here's what I can see. My x minus 1s do cancel. But this 2 minus x that's here is not the same as this x minus 2. So what I have to do instead is rewrite 2 minus x so that it does look like x minus 2. And so to do that, I have to factor a -1 out of this. So it's like saying take -1 and change both their signs. Okay, so if I take a -1 and change this 2 to a -2 and this -x to a positive x, that's kind of where I can rewrite 2 minus x as this. But this still doesn't look right, so I'm going to swap these two, kind of switch their spots. And so this would be the same thing as -1 x minus 2. Okay, that I'm going to replace with this. So let's keep going here because this was a lot of steps just till this point. We have 2x minus 3 still in its parentheses, but now I've rewritten -1 x minus 2, and there is still an x plus 2. And then the denominator is x minus 2 and x plus 1. Okay, so we now got to this point where we have everything written out that's not canceled still, but now I can cancel out the x minus 2's because those are the same. So let's, we're almost done here. Just to finish up, we still have to FOIL some of this stuff through. This -1 here, we generally write in the front. It's like a -1 like this, and then we're going to go ahead and multiply to get my trinomial on the top. The bottom is just going to be an x plus 1 because there's nothing else left over on the bottom. But let's go ahead and use FOIL for these two parentheses, 2x minus 3 and x plus 2. Again, FOIL or box method. I'm just going to quickly do FOIL. 2x squared, then we get a -3x and a positive 6x. So this would be a positive 3x. A -3 times a 2 would be a -6. This is the final answer. Sometimes that -1 can be written in different ways. It could be written in front of the fraction just as a negative. It could be written just like this, or just as a negative without the 1, because the 1 is not required either. So this is the final answer for this one. I'm sorry, let me clarify something real quick. I think I made a mistake here. This was -3x, and then 2 times 2x is 4x. So really it's 4x minus 3x, which is 1x. Sorry about that. And then this last term is still -6. So it should have been negative still 2x squared plus 1x minus 6 all over x plus 1. And this is how you would write the final answer. Okay, let's try another one, number 3. Still same idea, we're still multiplying here. So we have x squared plus 8x plus 15 over x squared minus 25. And we're multiplying to that x squared minus 10x plus 25 divided by 3x minus 15. So again, we are factoring all the pieces here. So starting with, let's see, actually I'm going to go ahead and write it down here because we'll need more room. Looks like it won't fit right there. So starting with the first one, to factor this, that would be x plus 3 and x plus 5. If you are not able to factor as quickly as I did there, take your time trying to write out the x if you need to. I'd rather you get it correct rather than rushing through and getting them incorrect there. But two numbers that multiply to get you 15 but add to get you 8. Then again, keep going. Here's one big fraction bar. Here's the next one. Same for the next, but it's x minus 5, x minus 5. Two numbers that multiply to get me positive 25 but add to get me -10. And then finally for the denominator, x minus 5, x plus 5. This is dots, or difference of two squares, where you take the square root of 25 and then you have a positive and a negative for it. And then the last one is just a GCF of 3. So it leaves me with 3 times x minus 5. So lots of x plus 5s, minus 5s. Let's go ahead and cancel out what we can here. X plus 5 is gone with this x plus 5. This x minus 5 and this one are gone. And finally, those two x minus 5s also. So all I have left on the bottom is a 3. And all I have left on the top is x plus 3. Can't cancel the 3's out. X plus 3 is its own family. Think of it as having parentheses around it if you'd like. But that's all you can do on that one. All right, now we move on to division. And if you think back to division from when we did like fractions, let me give an example with fractions. Same kind of one as like we just saw at the beginning. if it was 2/3 divided by, let's say 1/7, we would, actually, let me give a number. Let's do 3/7. Okay, so if that was the fraction, we would start by keeping the first fraction the same, then you change it to a multiplication and you flip this fraction upside down, like it's a reciprocal. So instead of 3/7, that becomes 7/3, and then you would just multiply across like any other multiplication problem. And then if needed, you would simplify and reduce and so on. So that was how we did division with numbers. Now we're going to do division with expressions. This same problem could have been written like this: 2/3 divided by 3/7. That doesn't look pretty, but it means the same thing, where you would still change it to 2/3 times 7/3. So if you see a fraction over another fraction bar, it just means to flip that denominator and make it a multiplication. So let's go ahead and try that on the next few problems. I have 2 or 3 more of those that we can go through for division. So here's our first one. This is similar to one that you see on the Michigan virtual test, I believe. I'm not sure if it comes up like this on the quiz, but we might see more with this later on. So here's the question: 4x plus 1, x minus 3, divided by x plus 3, x minus 4, x minus 2. But now there's one big division here, because all of this whole fraction is being divided by another one, and we have x plus 3, x minus 4, x minus 2 again. And then the denominator of this fraction is 3 times x minus 3. I know this looks complicated, but it's actually probably one of the easier ones, because what's about to happen here is I'm going to rewrite the first fraction kind of just as it is. And then we're changing this to multiplication and flipping this guy. So the numerator of this one, the top of it, is actually going to end up on the bottom. And the x minus 3 that's on the bottom here is coming on top. And so now it's just a matter of canceling anything that could be canceled. But if you notice here, nothing on the tops are the same as the bottoms. At first glance, some people see this and they try to like cancel these. Don't do that, because it doesn't actually equal it. The final answer actually looks like this: 4 times 3 is 12. For the numerator, I have x plus 1, and this x minus 3 repeats itself, so I put a little squared. And then for the denominator, we can just write x plus 3 squared, x minus 4 squared, and x minus 2 squared. Do not expect you to have to multiply all of those using FOIL or box method. That would take forever. So this is how you could leave your final answer. All right, and then I have a few more here just to wrap up with numbers 5 and 6. Just more division problems to hopefully get the idea that how division works. It's very similar, again, to multiplication once you just do that first flip. So this question is 6x, x plus 6, divided by 12x divided by x squared minus 36. So first step is flip just that second fraction. Let's keep the first one the same and change it to multiplication. So we have 6x over x plus 6 again, but times x squared minus 6, 36 moved up, 12x moved down. And now we're ready to start factoring. So 6x doesn't have anything to it, but the top here, this is dots, difference of two squares, so it'd be x minus 6, x plus 6. The bottom, there's a 12x, I'll put that first, and then an x plus 6 after it in its own parentheses. And we can do some canceling out, which is nice here. The x plus 6's are gone, the 12 and the 6 don't cancel, leaves me with a 2. 6 divided by 12 is 2 in the denominator, right, or 1/2 essentially. The x's cancel, and I'm just left with x minus 6 on the top there. So my final answer is x minus 6 divided by just a 2 on the bottom. So we were able to simplify pretty far down till just this answer. All right, we are going to finish up with just one more, and then we are all set here. If you do have any questions on any of these or on other ones, please either send me an email and I can jump onto Zoom to help you as well. So this last one is x squared plus x, or you can say 1x, minus 6 divided by x squared plus 2x minus 8. And then we're dividing that by 5x plus 10 divided by x plus 5. All right, so that is my problem. I want to, again, change it to a multiplication by flipping the second fraction only. So let's do that here. Actually, I'll fit that part up here, and then we can start factoring. So x squared plus x minus 6, that part stays the same. X squared plus 2x minus 8 stay the same, but then we have times. The numerator is now x plus 5 for this fraction, because it moves to the top, and 5x plus 10 goes to the bottom. Now you could technically simplify this fraction if it lets you, but this is not, you're not able to simplify any further with this. Don't try to cancel anything. That's just like, you can't just cancel the 10 and the 5 and make it 2. You can't just cancel the x's. So we do need to do a little bit of work here. So let's now factor the first fractions, top and bottom. So the first one would be x plus 3, x minus 2 would be the only way to get a negative 6 when you multiply them, but a positive 1x when you do FOIL and you get your inner and your outer terms. And then for the denominator, x plus 4 and x minus 2 would again give me negative 8 when I multiplied it. If you do need these x's, remember, feel free to draw them in. Same thing with this one, a negative 8 and a 2, or a negative 2. So at this point, we're not done yet. We still have these two other factors. We're going to just draw those up on the top. X plus 5 and the 5x plus 10 I can factor out as 5 and an x plus 2. All right, and then you would start canceling out anything that can be canceled. So just those x minus 2's, it looks like. Not very much here. And then let's try to simplify. So the top, now you have to multiply the x plus 3 and the x plus 5. So this would be x squared plus 8x plus 15. You would also have to multiply the denominator, all the factors together. I'm going to leave 5 there for a second and just multiply the factors first, or you could have done 5x plus 10 times this factor. It's up to you. So this would be, for these two multiplied together, x squared plus 6x plus 8. And then if you distribute a 5 everywhere into the denominator, it becomes 5x squared plus 30x plus 40, and the numerator stays the same. So although this looks like you didn't actually simplify it, you did actually simplify the best you could, because these don't factor any further. They don't cancel out anymore. All of these are completely simplified. So I just was able to multiply back to get them in this form, which is how Michigan Virtual generally leaves their answers. So if you have any questions on any of these, feel free to just email, or and then we can go on to Zoom if needed as well. All right, if you have, and then hopefully finish up that Google form if you have not already for attendance.